Write down the question at first. My handwriting is too bad, but try to understand that. A girl is riding a bicycle along a straight road with a speed of 5 meters per second. She throws a stone of mass 0.5 kg with a speed of 15 meters per second. The mass of the girl and the bicycle is 50 kg. As the speed of the bicycle changes after the stone is thrown. You have to just give me the answer of that question. So, what should be the answer? Let's see. I'm just giving you a time of 1 minute. Then just give me the answer that what kind of concept can be used here. When a girl, suppose just think that you are just riding in a bicycle and you are just throwing a stone with a speed of 15 meter per second. Then after you have just thrown that stone, then what is the change in the speed of you? Just think about it. It's very relevant and it's a very easy question. You guys can do it easy. Let me solve for you people. In this case, so what do you think actually? Funny Bhushan, girls, what do you think? That means, suppose you are just riding in a bicycle and you are having a stone. At that point of time, you are just throwing it with a speed of 15 meter per second. Then what you will see after just throwing that stone with that speed, that you will also feel some amount of, that means it's a one case of that of recoil velocity, right? You are just applying some force to throw a stone. That means the stone will also apply some force on you now, so your velocity will be affected, so you will get a new velocity. So in this case, at first you should find out the initial momentum and the final momentum. Okay, so from the change in momentum, that means the you guys know about the law of conservation of momentum, right? From that law you guys are able to understand that the initial momentum and the final momentum will be equal in that case, right? Because when you are having the stone, there will get one momentum, that's your initial, and when you just throw it, that will be your final momentum. Now let's calculate it. Now let's go for it. In this case, a girl is riding a bicycle with a straight line. It's having a speed of 5 meter per second, right? So initially the mass of the system, that is equals to the mass of the system, that is of 50 kg, right? The mass of the system, that is of 50 kg plus of 0.5 kg, right? Initially the girl was having that stone, so I can say that the mass of the system initially, that was 50 plus of 0.5, that is equals to 50.5, right? 50.5 kg. Now if you just see here, in this case initially it was moving with a speed of 5 meter per second. So initial speed, that means of u1, right? Initial speed, that means of u, that is equals to 5 meter per second. It is already given in the question that it is equals to 5 meter per second, right? So initial speed is given here, mass of the system is given here. So what can I find out? I can find out the initial momentum, right? What should be the initial momentum? The initial momentum, that is of the mass of the total system, that is equals to 50.5 multiplied by 5. What can be the answer? 25, 252.5, right? Sorry, kg meter per second will be there. Right, that kind of answer you will get. Here the mass of the system before throwing the stone, that is of the 50 kg plus of 0.5 kg, that is of 50.5 kg. The initial speed, that is of 5 meter per second. So the initial momentum, that can be 252.5 kilogram meter per second, right? So let's calculate the final momentum. What can be the final momentum here? To calculate the final momentum here, that means the girl have thrown that stone. So after the girl is just thrown that stone, the stone will move with a velocity of 15 meter per second, right? The mass of the stone, that is of 0.5 kg, we know that. Velocity of the stone, that is of 15 meter per second, right? And you guys, after just throwing that stone, the mass of the girl and bicycle, mass of girl plus bicycle, that is equals to 50 kg, right? And they will acquire a new velocity, and that velocity we don't know. We have to find out the change in velocity by the conservation of law of linear momentum. So what do you know about it? Let's calculate the final momentum, right? Let's calculate the final momentum and see that what happens here. So what can be the final momentum? Still now also, okay. Final momentum, if I just calculate for that, final momentum should be equals to mass of the stone multiplied by its velocity plus of mass of the girl and the bicycle, that is of 50 kg, and they will acquire a velocity of v, right? So just visualize yourself, you are just riding a bicycle, and at some time if you just throw that stone, so after that, uh, the rest of the part, that means you and your bicycle, the mass of you and your bicycle, that is of 50 kg, so you will acquire a velocity of v, that's a different velocity. So we just want to find out that velocity also in this case. So we know that according to the law of conservation of momentum, the initial momentum, that is equals to the final momentum, right? Initial momentum, that is equals to final momentum. So can I write down like that, that 0.5 multiplied by 15 plus of 50 multiplied by v, that is equals to 252.5. So just solve it and give me the answer. What can be the answer, everyone? That's way.
Sir, five.
5. No, 5 will not be there. Okay, well tried. Now in this case,
Sir, 5.1.
4.9. Okay, that is of
Sir,
7.5 now.
5.1.
Yeah,
Sir,
50v, that is
5.1.
equals to 252.5. So 50v, that is equals to 245,
25.
right?
245.
Hmm. So v equals to how much?
Yes.
Let's see. V equals to 245 by of 50 is a 4.9. So we have just got that is equals to 4.9 meter per second. So what can I say, that initially it was moving. It in the question it was asked that you have to find out the change in speed, right? So at this point of time, the solution is not finished till now. We have find out the final speed, right? We have found the final speed of the bicycle. So initial speed, what was the initial speed in this case? Initial speed was 5 meter per second, right? Initial speed was of 5 meter per second, but now we have got the speed as 4.9 meter per second. So what is the change in speed here? What is the change in speed?
0.1.
0.1 meter per second. That's very good. That's our answer, right? So the change in speed in this case, that is of 0.1 meter per second, right? Now whether the solution is understandable for everyone, if that kind of question is asked in that question, sorry, in the exam, I hope you guys are able to solve that. Girls, whether it is understandable. The whole of the thing, whatever we have just done here. Sure. Now in this case, what is done? Initially, suppose just you assume that you are just riding a bicycle. Okay. On a hillside road, you are just riding a bicycle and you are having a small stone, which is of 50 gram, right? That means of 0.5 kg. And at the time of riding of your bicycle, which is initially moving with a speed of 5 meter per second. The bicycle is initially moving with a speed of 5 meter per second, and now you are having a mass of 50.5 kg, right? That means the stone is in your hand. Now if I just calculate the initial momentum here, because when you are just throwing a stone with some force, that means the stone will also some small force on you, and that's why your velocity at which you was initially running, it will change. That means after just throwing that stone, the velocity of your bicycle will be changed. So we have to find out that change. After just throwing that stone, how much your velocity is changed, right? So for that, we need to take the help of linear momentum. Law of conservation of linear momentum. In this case, we have found the mass of the system. It's not about system, it's about you, your bicycle, and the stone. So that's why I have just considered it as a mechanical system. So its weight, that is a 50.5 kg, the speed, that is a 5 meter per second, initial momentum, that is equals to 252.5. Now we know about the mass of the stone, that is of 0.5 kg, the velocity of the stone, that is of 15 meter per second, where the mass of you and the bicycle, that is of 50 kg, and the velocity after throwing the stone, that is of v. If you just don't do that actually, but if you just do that, suppose at the any of the afternoon, you just start riding your bicycle and you are just having a stone on your hand, and if you just throw it, that means at that point of time you will see that the velocity of your bicycle will somehow be changed, a slight change will be seen. So we have to find out that slight change. Okay, so in this case, the final momentum, that is equals to the momentum of the stone, this is the momentum of the stone, and that is the momentum of the bicycle, right? So in this case, what you will see, the initial and final momentum will be equal, right? If the initial and final momentum are equal, so here the total part we have just made equal, right? We have just equal this final momentum, that is equals to this initial momentum. And after solving that, what we have just got, that is a v equals to 4.9 meter per second. That is the velocity of your bicycle now after throwing the stone. So what is the change in velocity? If we find out change in velocity, that means your bicycle was initially moving with a speed of 5 meter per second, but now it is moving with 4.9 meter per second. So there is a small slight change. So what is about that change? That is of 0.1 meter per second. Now guys, whether you are able to understand, which part is
Yes,
confusion, just
sir.
tell. Okay. Now girls, just give me a reply here. Any doubt? Okay, okay, that's good. Now let's move to the next question, right? Now let's move to the next question, and we just want to solve that. This is the first question. So the next question, that's it is about all of the applications of the concepts whatever you have just learned here. That means in that case, suppose lots of free body diagrams we have understood here. But in that case, when you are just asked a question, there the application will be there. Okay, they will not give you a ready-made free body diagram. Okay, they will not give you a ready-made free body diagram. You have to just draw it in some cases, and if they are good enough, in some cases they will also provide a free body diagram to you people. Now just move to the next question. Okay, let's see you guys are able to solve that or not. Now from today, that's another good news, that the recording of the whole class will be available on the YouTube channel that we had, that's a physics field. The whole class recording, whatever we are just doing here, all of the things will be available in the YouTube channel. If some of the people are having that network issue, they can watch that video in that YouTube channel. I will just upload it in within 2 p.m. okay, because I'm having another class of class 12 at 12. That's fine. Okay, let's see what's the answer. Anyone here? Okay, that's very good, Maria. Okay, now let's move to solve it. Okay, lots of girls have given me the same answer. That's very good. Now if I just draw a diagram of that lift, suppose that's me. Okay, in that lift, that's me, and I'm having a weight of I'm having a mass of 50 kg, and I'm just standing on a weighing scale on a lift. And if the lift is accelerating in the downward direction, suppose this is the mass, sorry, this is the weight of me, and in that case this is the apparent weight, that's the reaction force, right? So it is accelerating in the downward direction. That means the weight of myself is greater than the reaction force. So in this case, mg minus of r, that is equals to mass into acceleration. So what the formula for r? R equals to m into g minus of a. So in this case, mass, that is equals to 50 kg, g is equals to 10, acceleration equals to 9. So I will get 50 Newton. That's a very good answer, all of you. Now let's move to the next question. This is the position time graph of a body of mass 2 kg. It's given here, and you have to find out the impulse on the body at t equals to 0 second to t equals to 4 second. So in this case, it is actually the position time graph of a body of mass 2 kg, right? Here in this case, we have not given any kind of force here. So what can be the force that is responsible for its motion? And what is the definition of impulse? In the definition of impulse, you guys will see that means suppose if you are applying a force for a very small amount of time, right? You are just applying a force for a very small amount of time, and in that case it will move a large distance. Suppose you are just playing a cricket. I have just given that example in the previous classes also. You are just playing the cricket, and a ball just comes to your bat, and you are just hit that ball and it becomes a six. That means the contact between the ball and the bat, that is a very for a very small amount of time, but the force, that's a very large, right? So a large force that can be applied on a body for a very small amount of time, for a very small amount of time, that is known as an impulse. So in this case, we need to know the force that you are applying on that object. Otherwise we can calculate it in a different manner. So how can we calculate it? The change in momentum or the impulse, that is, in this case you guys will see that when you are just hit that ball, that means the momentum of that ball, it will change, right? Just visualize that concept. That means a ball is coming with a speed of 50 meter per second, and after just hitting that ball, it just starts moving with 80 meter per second. So there should be a change in momentum. So by that change in momentum, you guys are able to find out the impulse on that given object. right? So how to find out that? Impulse, that is equals to, that is the change in momentum, right? So mass multiplied by del v. Can I write down like that? Impulse actually the change in momentum, so I can write down it like that, that it is equals to mass multiplied by del v, right? So if it is like that, we know that for the case of, you can write it dv also, okay, the change in velocity. So it can be written as dx dt, sorry, in this case we have used del, so it should be del x del t. So what is the change in position with respect to time? In this case you guys can calculate it. So 2 multiplied by, what is the change in position? Change in position is from this position to this position, right? That is of 3, and the change in time, that is of 4, right? So what should be the answer? That is equals to 1.5 kilogram meter per second, right? Why that the solution is understandable, everyone. Impulse can be given by the change in
Yes, sir.
momentum of that body. So we can write down it, that is the mass multiplied by change in velocity. Change in velocity, actually you guys are at class 11, so I'm not writing v2 minus v1, I'm just writing del v here, right? So it can be represented as del x del t. You guys know that del v can be represented as del x del t. That means the change in displacement by change in time. So I have just substituted the value and we have just got that answer.
Can you repeat it again?
Sure, I can repeat it again. So in this case, this is the actually the position time graph of a body of mass 2 kg, right? And you have to find out the impulse of the body at t equals to 0 to t equals to 4 second, right? So there is a limit is given at t equals to 0 to t equals to 4 second. So the change in time, that is equals to 4 second. Now if the change in time, that is equals to 4 second, and the change of its position, what is the change of its position, Fanibhushan? That is from 0 to at this peak point. So the change in position, that is equals to 3. So if the change in position is 3 and the change in time, that is equals to 4, so I can do, that is the impulse equals to mass multiplied by change in velocity. Change in velocity, funny motion, change in velocity can be represented as change in position with respect to change in time. Can I do like that? It is not actually the differentiation. Don't think as a differentiation. It is actually represented as the change in position with respect to change in time. Okay. So in this case, I have just written it in this way and we have just got the answer, the 1.5 kilogram meter per second, after substituting the change in position and the change in time in the given expression. Now Funny Bhushan, any doubt?
No, look, sir.
Okay, that's good. Now let's move. Now let's move at which position? Let me just slide it down. Okay, let's move to the new slider. Actually, it's over. That's right. It is actually whatever the questions that I am discussing, it is all about the previous year questions that has already come in the exam. So these are the important questions that may come in your exam. So that's why I'm start discussing that one. Okay. So in this case, now just move to the next question. Now, whatever the free body diagrams you guys have learned, right? From that free body diagram, if any questions is asked, just understand my words. From that free body diagram, if any questions is asked, now at first draw the free body diagram given in the question. Okay, whatever the free body diagram will be given in the question, at first draw the diagram, then do the modifications. Whatever you will write down, mg, in the above there will be some tension, whatever you will just make that change, just do that modification after you write down their free body diagram. Okay, so let's see how much you guys are able to solve that type of questions as well, right? Now let's move to the next question. This is a question number how much? I hope this is a question number 3, I think. Now let's move. Now two masses of 5 kg and 3 kg are suspended from a massless inextensible string, massless inextensible string, as shown in figure. They will provide you some diagram as shown in figure, right? So calculate T1 and T2 in this case when the whole system is going upward with an acceleration of 2 meter per second square. So here assume g equals to 9.8 meter per second square, right? In this case just assume g equals to 9.8 meter per second square, then try to solve it. Okay, oh sorry, I have to give the diagram as well, right? So this is actually the diagram that is given in the question. Here are the two masses, one is like that, another is like that. Let's see, this is of a different case. I have not discussed that case in that class, and let's see how much you guys are capable to calculate it. This is actually the T1, this is actually the T2, and this is the 5 kg. Let me write down that 5 kg in that. This is a 5 kg, this is actually a 3 kg. Now the time is equals to 1 minute and you guys will calculate. Let's see whether you are able to solve that or not. It's actually the test of me that whether I'm able to make you guys learn or not. Let's see. Okay, let me help you out in this case. Time is already up. So in this case the total system is moving in the upward direction, right? The total system is moving in the upward direction. So just analyze one by one. So for the case of 5 kg, case of 5 kg, this is actually our T1, this is in this direction, this is our T2. Okay, in this case the T1 and T2 both are in upward direction, but actually the diagram can be changed in a different way also. In this case we have analyzed T1 and represented it in this diagram, and T2 should be like that, because if 5 kg is applying a tension force on 3 kg, then 3 kg will also apply the same tension force on it according to Newton's third law. And here in this case, sorry, this is not actually m, this is of 5 into 9.8. that amount of weight will also be applied in the downward direction. So the weight of the 5 kg mass, that is of 5 into 9.8, right? That is of 49, I think, 49 Newton, right? Now what are the forces that we got here? That is of T1 is moving in the upward direction, T1 is in the upward direction, T2 and the weight of the object are in the downward direction. But in this case the total thing is moving in the upward direction. That means T1 is greater than the both of them. So T1 minus of T2 plus of 4.9, that is of 5 into A. 5 into acceleration, that is a 5 into 2, right? In this case, t1 minus of t2 minus of 4.9. So in this case, t1 minus of t2, that is equals to 4.9 plus of 10, that is equals to 14.09, right? So it is actually a 14.9. So we have got an expression that is equals to 1, right? So we have got that expression. So let's move for the analyze of 3 kg mass, right? So if you just analyze for the case of 3 kg of mass, so in this case there is a tension force that is of T2, there is a mass that is of 3 into 9.8. So what is that? 3 is 24, 2 carry 29.4, right? 29.4 Newton. It's the weight of that 3 kg of mass. For that object, the weight is working in the downward direction and there is a tension force. Now in this case it is given as the total system is moving in the upward direction, so it is very much clear that T2 is very much greater than its weight. So T2 minus of 29.4 Newton, that is equals to 3 into A, right? In the previous case, what we had done, in this previous case, all the system is moving in the upward direction. That means T1 is very much greater than its 49 plus T2. So that's why I have just subtracted T1 minus of T2 plus of 49, that is equals to the net force, that is a 5 into A, right? In this case also, T2 is very much greater than its 29.4. So T2 minus of 29.4, that is equals to 3 into A. So in this case, T2 minus of 29.4, that is of 3 into 2, 6. So T2 will be equals to 29.4 plus of 6, that is of 35.4. So T2 we have just got as 35.4, and T1, what will be the value of T1? That is, let's just calculate it. That's very good, Nilim. The answers are correct. So T1, that is equals to 35.4 plus of 14.9, right? That is of, oh, sorry. This is, there I have mistaken. This is actually 49, but I have represented it as 4.9. Oh, sorry. That's my mistake actually. Due to my bad pen here, there a point comes. The point should not come here. There is a correction actually. There is a dot comes due to my pen, and that's why the mistake happens. It is actually 49. It will be 59, right? So in this case, it is actually a 59. So the expression in this case will be changed also. In this case, the expression will be changed in that way, that is T1 equals to T2 plus of 59. So what is the value of T2? That is equals to 35.4 plus of 59. So it's a very greater force, right? So what is T1 after calculating? What I will get? The point 4 should be outside, 84.4 Newton. That's the answer we can get. Nilim, there is a small mistake you have also in T1. That should not be 45.4, I think, because in this case, if you just analyze it, in the case of 5 kg as well as in the case of 3 kg, if you just analyze it, it will become in this case as T2 equals to 35.4, but T1 equals to 84.4 Newton in this case, right? Whether it is understandable, everyone? Is there any doubt from this question?
No, sir.
Okay, girls, any doubt? Okay, that's very good. In this way, you have to just remember the process, that in which way it is accelerating. You have to just keep in mind, if it is accelerating in the upward direction, that means the upward force is very much greater than the downward forces. That's why we are able to calculate that question in this way. And if the body will move in the downward direction, that means the downward forces is very much greater than the upward forces. We will see that application also in the next class. Okay, and I hope we'll start a new chapter as well in the next class. That is the next chapter, I hope, should be a gravitation. Okay, so keep practicing all of the questions. I will give you the assignment on the basis of this chapter as well. So thank you so much for the class. Bye bye everyone. And the session is already
Thank you,
recorded.
sir.
Okay, it is already recorded. Okay, how to stop it?